so we're going to multiply and divide rational expressions. To do that, you do have to be able to simplify a rational. So the property we're simplifying is that I have a times c, right? If that is divided by b times c, then what happens is the c's will simplify to 1, and I have, that's the same thing as a over b. So let me show you how that works more in the real world, okay? So let's say I have 15 divided by 65. Well, I can think about that as 3 times 5, because 15 is 3 times 5, divided by 13 times 5. Well, because 16 is 13 times 5, now if I think of it this way, what I can do is simplify those 5's, and that fraction would be equal to 3 over 13. That concept that we use to simplify fractions is the same concept we would use even if our fractions had x's and y's in them. So let's say your fraction has like 4 times x plus 3 divided by, I don't know, x plus 3 times x plus 3. Well, I have the same factors in the numerator and the denominator. So this x plus 3 over x plus 3 would simplify, and I'd be left with 4 over x plus 3, and that would be my fully simplified fraction. So let's do some more examples of this with x in it, okay? Okay, so now we have some examples, and our examples, the directions are just to simplify. So the first thing I want to do is break this into factors, or the terms that multiply to give me these trinomial or the binomial. So in this case, I'm going to factor this guy, so that's going to factor into 2 parentheses. X times x would give me x squared. I need 2 numbers that multiply to give me 12, and add or subtract to give me negative 4. Hold on one second. Okay, so let's figure out what that would be. That would be, let's see, 2 and 6? Yeah. So if I have positive 2 and negative 6, then I'm going to come down here and factor this right here. Now this binomial happens to be a difference of squares. So I know it factors to x plus 2 times x minus 2. Then I'm going to see if I have any factors that are the same on the top and the bottom. I do. So I can simplify those, and I'm left with x minus 6 over x minus 2. Now I would be finished. There's one thing I do want to make sure. I want to make sure I don't divide by 0. So if x minus 2 is equal to 0, that would be bad for me. So what I'm going to say is this is my answer in the situation that x does not equal 2. Because if x were positive 2, I'd have 2 minus 2 in my denominator. That would give me 0. That's no fun. Okay? Here, same thing. I need to factor this. So I'm going to factor my numerator. X times x gives me x squared. Multiply to give me 3, add to give me negative 2, so that's going to be 3 and 1. It's going to be some combination of 3 and 1. Looks like I need a negative 3 and a positive 1. Now it's time to factor the denominator. So x times x gives me x squared. 2 and 3 give me 6, so let's do like 2 and 3. It looks like I need a negative 3 and a positive 2. Okay, now that I have that fully factored, I'm going to look for terms that are the same on the top and the bottom. So I'm left with x plus 1 over x plus 2. And in this case, I'm going to go ahead and make that caveat. Let's make sure x is not negative 2. That way my denominator is not 0, and we're set to go. Okay, so the next thing we have to be able to do is multiply rationals. In order to do that, there is a property for that as well. So if I have a ratio or a rational number, a fraction times another fraction, what I do is I multiply the top and then I multiply the bottom. So let's look at that in a polynomial. So I have 5x to the third over 2xy squared times 6xy to the third over 10y. So let's think about what this means. So I can multiply straight across. So this is 5 times x times x times x, right? X to the third times 6 times one of these x's times 3y's. Running out of space. There we are. And then let's see what's happening in the denominator. So I have 2 times x times y times y. Then I can multiply by this next one as well. So what I want to do is see if there's anything I can simplify in the numerator and the denominator, okay? So I can already see, let's see, I got some x's that need to be canceled out. So I have an x here and an x here. I have a y here and a y here, y here, 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 and here. I can also simplify some of these numbers. So 5 goes into 10 2 times. 2 goes into 6 3 times. Let's see what's left. So what remains is I have 3 with 1, 2, 3 x's, x to the third. And on the denominator, I only have a 2. So this fraction was actually super simple. It was actually 3x to the third divided by 2. So let's do some examples with this property. So in this example, I'm going to multiply these two ratios. And to do that, I do see that I have like an 8 over 2. So I'm going to go ahead, let's see, do I want to simplify that first? I don't know, let me think. No, I don't. Okay. So I'm just going to multiply straight across, right? So I have 8 times 7, let me get a different color. 8 times 7 is 56. X to the third times x to the fourth is x to the 7. Y times y to the third is y to the 4. Then I have in the denominator, 2 times 4 is 8 times x times y squared times y, that's y to the third. So now I have this fraction. I want to go ahead and simplify this fraction. So I'm going to come to the side for space. So 56 divided by 8 is 7. So I have 7, x to the 7 divided by x is x to the 6, y to the 4 divided by y to the 3 is y. So not really a bad fraction after all. So let's try that with a bigger rational expression, okay? So I'm multiplying this ratio times this trinomial. Now the thing to remember is that this trinomial is entirely in the numerator. So I'm technically multiplying by this trinomial divided by 1, okay? And when we multiply straight across. So this is actually the same thing as x plus 2 times x squared plus 3x plus 9 divided by x to the third minus 27. Because if I do x to the third minus 27 times 1, I would get that same thing. Now what I like to do is go ahead and factor this denominator. It is a difference of cubes. So I'm going to go ahead and factor this denominator. So that would give me the same numerator. I'm not going to change my numerator. And then I'm going to factor my denominator because that's x to the third, and 27 is 3 to the third. So that would be x minus 3 times x squared plus 3x plus 9. Now that's super fantastic because I can see that these two are going to cancel out. And I'll be left with x plus 2 over x minus 3. Let's make sure I didn't accidentally make anybody 0. I don't think we did, so I think we're good here. Okay. And lastly, we do need to talk about dividing rationals. So when you're dividing a rational, and here's the property you would use. So if a over b is divided by c over d, then that's the same thing as a over b times d over c. So basically we just took the reciprocal of this second fraction. You take the reciprocal, and that equals, and you multiply them together just like you would multiply before, so just straight across. Okay, so let me show you an example of that. So let's say I have 7 over x plus 1 divided by x plus 2 over 2x minus 3. I would keep that first fraction, 7 divided by x plus 1, times, and then I would take the reciprocal of that second fraction. So x plus 2 is now in the denominator, 2x minus 3 is in the numerator, and then I would multiply straight across. So 7 times 2x minus 3, and then x plus 1 times x plus 2. And that would be my solution. Let's look at one that's just a little bit more tedious, I suppose. So let's look at this one right here. And I'm dividing again. So my first fraction is going to stay the same. That first fraction is still going to be 7x over 2x minus 10. That second fraction, I'm going to take the reciprocal of that fraction. So that would be x squared minus 11x plus 30 in the numerator. And my denominator is x squared minus 6x. Now, before I start multiplying, I'm going to go ahead and factor these, because I know if I have the same factor in the numerator and denominator, they cancel each other out. So, or simplify out. So, I have 7x. I'm going to take the GCF of 2 out of this one. So, I have 2 times x minus 5, just in case that's helpful. I don't know if it will be. And then, let's see. I also have, so in this numerator here, I'm going to factor that. So, x times x gives me x squared. 30, I need two numbers that add to give me 30 and subtract to give me 11. Or multiply, excuse me, they multiply to give me 30, subtract to give me negative 11. Oh, you know what, I think I'm going to use negative 5 and negative 6, because if I add those, I get negative 11. And then down here, there's a GCF of x, so that would be x minus 6. And then I'm going to look and see if I have anything that's the same in the numerator and the denominator. So x minus 5 was the same, and then x minus 6 also. Oh, and a regular x. Look at that. Go ahead and cancel that. So what I'm left with is 7 over 2. That is it. This whole thing is 7 over 2. Now there's some things that x cannot be, so let's go ahead and make sure that doesn't happen. So in my denominator, let's go to this factored one. Okay, I know x cannot be 5 because that would make this a 0. X cannot be 0 because obviously I don't want to multiply anybody by 0. And x cannot be positive 6. I don't want that to accidentally be 0 either. There we are, 7 over 2 in the instance that x is not 5, 0, or 6, which of course would nullify all of our work. Okay, let's do one more, because sometimes it looks a little bit different, so let's look at one other instance, and I believe we are on example, let me look. Okay, we're on example 6, so number 6, here we go. Let's do 6x squared plus x minus 15 divided by 4x squared, and then that whole polynomial is going to be divided by 3x squared plus 5x. Now, in this case, when you see a problem like this, a lot of times students get really confused because this doesn't look like a fraction. Remember, since this whole polynomial is in the numerator, it is a fraction and his denominator is 1. So when I go through to multiply by the reciprocal, I'm going to put that 1 in the numerator. So my first fraction would stay the same, 6x squared plus x minus 15 over 4x squared, and then I'll multiply by the reciprocal of this second fraction, which is 3x squared plus 5x. Now again, before I multiply all the way through, I'm going to go ahead and factor this to see if there's anything that, you know, could go ahead and like simplify or something. So this first one, I'm thinking that's going to be 3x and x. So that's how 2x, excuse me. 3x and 2x. I ran out of space. That's a 2. 3x and 2x. That's a 2x. 2x. Okay. And then 5. And because if I do 5, no, if I do 5 here. Yeah. So let's do 5 here, okay? And then this will just be 4 x squared. I don't really know how to do that. And then 1 over, now this is a GCF of x, so that leaves me with 3x plus 5 here. Oh, now that is handy. Do you see it? So I have a 3x plus 5 here, 3x plus 5 here. So multiplying straight across, that leaves me with a 2x minus 3 in the numerator and a 4x to the third in the denominator, x squared times x. And then let's make sure I don't accidentally turn anyone to a 0. So x cannot be 0, because if I did, I'd have 4 times 0, which is 0. And x cannot be negative 5 over 3. Right? So if I had negative 5 over 3, then 3x plus 5 would have been 0. We'd had to divide by 0. Can't do that. So we are set there. So that's how you do that. And good job.